I can do to help. Today we're going to continue with the quadratic formula day 2. So we're still sticking with that formula we already looked at. So if we need that again, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Right, it's either x equals, y equals, w equals, whatever our variable is for the problem. Remember, also our rule when we're dealing with the quadratic formula is that it has to be set equal to 0. So we need to make sure we're still sticking to those rules that we had before. Today, when we look at the quadratic formula, we're just going to be dealing with what happens when it's not a perfect square underneath the square root. So steps are going to be the same, formula is the same, process is the same, but we just won't get a perfect square. Okay, so we're going to start off with a pretty straightforward one. In some ways, students actually think these are a lot easier. Sometimes they are less work. Sometimes they're a lot more work. So we'll start sort of with the simple one. So let's say we have x squared plus 5x minus 1 equals 0. Same steps we looked at before. Step 1 is we're going to figure out a, b, and c. So a equals 1, right? When we see nothing in front, it's a 1. Okay, b is whatever's in front of the x. So in this case, b is 5. Sorry guys, I know there's more shadows on my paper here. I just don't have great lighting in my house. Especially in the room I'm in, I'm working on it. I'm sorry. Hopefully we're okay. C is gonna equal negative 1. Okay, so if we use this and we put this into our formula, we will say negative b, so negative 5. Plus or minus b squared, so 5 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, so all over 2 times 1. Okay, once we plugged into the formula, our next step that we said we would do is that then we were just going to look at this stuff underneath the square root. So we're only going to focus right here at this stuff, right? You're not typing the square root into your calculator. If you started that habit yesterday, stop because it won't continue to work. Okay, so in our calculator, we're putting exactly what we see under the square root. So parenthesis 5 close parenthesis squared minus 4 times 1 times negative 1. Again, I linked a scientific calculator on the homepage of Canvas, so if you need one, you can grab it from there. Okay, we get 29. So we'll have negative 5 plus or minus the square root of 29 all over 2. Okay, then our next step is going to be to take the square root. So if in our calculator we do, okay, the square root of 29 is blah, right? We get this big old long decimal. So this big old long decimal, remember, tells us that it is an irrational root. It's not a perfect square. So if it's not a perfect square, we need to go back to our basic rules of radicals. So if 29 is not a perfect square, we want to get it in simplest form. So we'll take 29 and we will try to prime factor it. Now in this case, 29 is prime, so we can't do anything else, which means this is in simplest form, which means we're done. Okay, so our answer would just be x equals negative 5 plus or minus the square root of 29 all over 2. Now, please understand that this is 2 answers. The first answer is negative 5 plus the square root of 29 over 2. And the second answer is negative 5 minus the square root of 29 all over 2. Okay, so there are 2 answers. We're just writing them combined together in one. It's totally fine to write your final answer this way. This is what we see the majority of the time. We just want to make sure that we understand that that really is 2 different numbers. Okay, and then at that point, my student's like, well, wow, that's way easier than what we saw yesterday. And like I said, well, that's great. If there's nothing we can simplify and we can stop there, this is fantastic. The problem is that we can't always do that. So let's look at a second problem here. And before we even look at this problem, I want to talk about a concept that we've done before. It's just been a while because we're going to need to pull that skill back out. So remember when we had something like we were solving for y I know, right? Way back when. Okay. And if we wanted to solve this for y, we would undo multiplication with division. And if we divided over here, we knew this was the same thing as saying 8x over 2 plus 12 over 2, right? And we could divide these both individually. And we really didn't even write this first step down. We just recognized we could write it in both places. And 8 divided by 2 would give us 4, and that x just stayed the same, right? It never played a role. It just kind of followed along. Okay, that's a similar idea to what we're going to have today. So if we have something like 4 plus or minus 6 square root 7 all over 2, we want to understand that that 2 can go into each of these. It can go into the first one and it can go into the second one. But just like up here where that x had nothing to do with it, same thing here, this square root of 7 has nothing to do with it. It's only the coefficient. It's only the number in front. Okay, and so we could say 4 divided by 2 is 2, and 6 divided by 2 is 3. Okay, now you might say, well, then why don't we just write it in both places? Well, the formula doesn't have it set up that way. Okay, so if we look at a problem, how about we have, flipping back and forth here between papers, 3x squared plus 2x equals 14. So the first thing that we would ask ourselves is this in the correct form to use the quadratic formula? And hopefully we would all agree that the answer to that question is no. This is not in the correct form because it does not equal 0. Okay, so to get this to equal 0, right, we know we can move things around. So we'll move a positive 14 by subtracting 14. Okay, and this one is an x squared, and this is an x, and this is nothing, right? It's just a constant. So nothing gets combined. We just get a trinomial here. Equals 0. Now we are in the correct format. So now we can use the quadratic formula. Okay, so we'll say A equals 3. B equals 2. And C equals negative 14. Okay, and we'll start plugging into our formula. So we'll say negative b, the opposite of b. So negative 2 plus or minus, right? Big, long square root. It needs to go all the way across. B squared, so 2 squared, minus 4, times a, which is 3, times c, which is negative 14, all over 2 times a, so all over 2 times 3. Okay, and then we're going to do the stuff underneath the square root. Again, you can just pull out your calculator if you'd like. So parenthesis 2 parenthesis squared minus 4 times 3 times negative 14. Okay, and I'm getting 172. So now I have negative 2 plus or minus the square root of 172. All over 2 times 3 is just 6, right? We're not writing that as a separate step. Okay, so if we check the square root of 172, okay, just like the last problem, big old decimal, right? It's an irrational number. Okay, so we don't just want to stop here. We always need to check and see if it's something that we can simplify. So we want to take this 172 and use our rules of square roots, right? And start simplifying. So maybe I want to split 172 into 2 and 86. Again, it doesn't matter what you pick as long as mathematically speaking you're correct. So 2 times 2 times 43. And again, the question is often, well, how do I know when I need to simplify? I mean, you just always have to check. Okay, if you find pairs, you can simplify it. If you don't find pairs, then you can't. Okay, this one we do find pairs. So this becomes negative 2 plus or minus. Now, instead of writing the square root of 172 here, I'm now going to put 2 square root 43. All over 6. Sorry, my desk is shaking. It's still not a great setup. Okay, but again, now we're still not done. Now we want to use those same rules that we were talking about to start with and see if there's anything that we can reduce. I'm sort of going to use this little highlight color. It's hard to see, but I just want you to sort of see where I'm looking with my eyeballs. Okay, so I want to ask myself, can I reduce those? So I'm going to say, is there anything I can think of, okay, that will go into 2, 2, and 6? And those are all divisible by 2. I can reduce them by 2, right? So 2 over 6, I can reduce. So 2 divided by 2 is negative 1. 2 divided by 2 is 1. And 6 divided by 2 is 3. Okay, and now I am reduced, and so this would be my final answer. Okay, now keep in mind, this step from here to here is the same thing that I would have done up here, right? So if I had 12y equals 10x plus 9, right? And I'm dividing, I would see where I could reduce, but because we have this square root here, we're trying to see where we can reduce all 3 of them. So now instead of just considering one fraction and another fraction, because we're not dealing with slope, which is what we had above, we're going to look at all 3 numbers and see what we can reduce. Okay, we couldn't reduce anything over here on our first problem because this has a 1 sitting here. And so if we look at all 3 of these numbers, -5, 1, and 2 don't have something they're all divisible by. So if you can't prime factor and simplify the square root, there's not going to be anything that you're able to reduce. You'll only be able to reduce potentially if you can simplify that square root. Okay, so our final answer is x equals -1 plus or minus 1 square root 43. Keep in mind that this one is optional. This one is not. That one has to be there. Okay. So let's look at one more here. Let's say we have 8y squared minus 2y plus 22 equals 0. Now, first thing, hopefully we look at this and we realize there's no way we want to solve this by any other method that we've looked at. We don't want to solve this by taking a square root because it has a y to the first power. Factoring, I mean, I guess if you want to take 8 times 22 and then make an entire list and see if you can get something that gives you -2, because you're not guaranteed that it'll be factorable. So you'd just be checking and potentially wasting time. Completing the square, right? We don't have a equal to 1, so we don't go there. So really we want to use the quadratic formula. Okay, we're in the correct format. It equals 0. So a equals 8. B equals -2. And C equals 22. Okay, so once we're here, we're just going to start plugging into our formula. So -b, so the opposite of -2. So +2 plus or minus b squared, so -2 squared minus 4 times a times c, right? Big long square root, big long fraction bar over the whole entire thing. All over 2 times 8, 2 times a. Okay, so again, we're going to go underneath that square root and type in exactly what we see. So parenthesis, -2, close parenthesis, squared. Here you have to have those parentheses because we're squaring a negative. Okay, and we get -700. So we have 2 plus or minus the square root of -700. And at that point, hopefully your brain goes, oh, I can stop writing. Because whether it's step 1 or step 500, if we get this negative underneath the square root, this is a no real solution. Okay, we can also write this as NRS. Okay, so I know the biggest one is probably